going to start off with Kruskal's algorithm. So Prim's and Kruskal's algorithm both will find a minimum spanning tree for a graph. I'm going to put the complete back up here just so we get the word. So in this gap at the top here, you can fill in this. You can start at a spanning tree. The minimum spanning tree is a spanning tree that has the minimum weight among all the possible spanning trees. So remember, a tree is just a part of a graph that has no cycles in it. It's all branched out like that. A spanning tree includes all of the nodes in a graph, and a minimum spanning tree is on a graph that's got weights on its arcs, so a network, and it has the minimum weight getting to all of those nodes. This does have real life applications. So examples of real life applications here are TV company laying cables, houses, council wanting to create roads. It says text messages as well. Prim's and Kruskal's algorithms both do the same thing, just in a slightly different way. Neither one's better than the other, really. They're both about the same. They're both the same efficiency. So once you've filled in the real life applications that you can put in this, what does it do for Kruskal's algorithms? So Prim's and Kruskal's algorithms both find the minimum spanning tree for a graph with weights. Okay, so the steps for Kruskal's algorithms are listed here, but I'm gonna just do an example. If you haven't filled it in, don't worry too much about it. Right, so I'm not going to talk to this. I'm going to do this example at the bottom. So we've got a graph here with our weights on it. I'm being asked to find the minimum spanning tree for this network. Okay. I'm going to do it using Kruskal's algorithm first, and then we will do it using Prim's. So Kruskal's algorithm is all about the arcs on this network. Okay. The first step of Kruskal's algorithm is to list all of the arcs in ascending order. So we've got all of these weights on here, and I'm going to list them in increasing order of size. So I'm going to start off with EF, which has a weight of 8. Put them down there. I might cross them off just to make sure that I've got them all in, or they don't. I've then got DF, which is 10. It doesn't matter whether I put DF or FD, just for purposes. Then I've got 2 12s. I've got BD and DE. It doesn't matter which order I put those in. Both with 12. Got a 13 for BC. I've got 14 for BC or CE. I've got 15 for BC and CE, doesn't matter. And then I'm on to 19 for A. And 20 for A. First step is to list these in ascending order. Then remember, a minimum spanning tree can't have any cycles in it. So what we're going to do is we're going to build up our tree by adding on each of these arcs, unless it makes a cycle, and then we're going to reject it. Because remember, a cycle is just like where you can go around your graph. So like F, E, D, F is a cycle. We don't want any of those in our minimum spanning tree. What you need to do for Kruskal's algorithm, it will always say list the arcs in the order that you consider them. So as we add them on, I'm going to build up a list. I'm also going to draw it as I go along as well. So if you've not got loads of space, but if you can squeeze in a little diagram. Here. I'm going to tick and cross these as I go along, so which ones I've added on. So first off, I'm going to add on EF. That's fine, doesn't make any cycles, so I can add on EF. So it's that. Next one, DF. Check if it makes any cycles. Well, it doesn't. That's fine. So I can add DF on as well, and I'm going to add it onto my diagram. BD, if I was to add that onto my diagram, it's fine. I can't go around in a cycle on there, so I can add BD. That's fine. But DE is the first one I can add on. DE, if I was to add DE onto my diagram, it would make a cycle around here, around DEF. So I can't add that one, so I'm going to reject that one. That's next. BC is okay, I can add that one on. Doesn't make any cycles. Put that on my list. EC would make a cycle. I joined it up along the bottom there, so I can't add that one on. DC would also make a cycle. If I was to add that on, I'd have one around DCB. That would be a cycle, so I can't have that in there. AB is okay though. Doesn't make any cycle, so I can add that on. And lastly, AD, I can't add that on. I've got a minimum spanning tree there anyway, because all of my nodes have been joined. Okay. So you need to write your arcs in order. Send in order, and then you need to indicate whether you've accepted or rejected them. So just a little ticking across is fine. And it says list the arcs in the order that you consider them. So that's just writing the list out. State the weight for your tree. So we're going to add up. We've got 8 plus 10 plus 12 plus 13 plus 19 for each of these that I've added on. And that gives me 62. They always like to put these in context. So this is talking about gritting roads. So it says all that's required for these bricks is that no villages cut off. So that every node needs just one arc coming out of it. And the total length of roads to be good for as small as possible. So it wants us to find a minimum spanning tree for this one and state its weight. I'd like you to have a go at this, please. It's a bit of a bigger network. You want to
Okay.
So here's what you should have got. So you have to put these in order, and then you have to add them on here. Cycle. So you should get a total weight of 99. Yeah, we don't find it would look something like this if you thought that. I'm not going to go through. Okay, which thing what have we got? Then for part B, it says the road between Golfer and Palmer, so G and H, they've decided to be too steep to work with. So if you took out G to H, you're taking out this arc of length 6. D and G wouldn't be connected up to the main spanning tree, so you need another way of connecting those up. If you have a look down your list then, so if you took out G to H, which is the first one, you would then be okay to add on D to H down here. So that would be what you'd replace it with. It just increase the weight of your spanning tree, minimum spanning tree by 4, because you're adding on 10 instead of 6. So your total weight then would be up to 3. Okay.